Hello and welcome to a lesson on multiplying fractions and mixed numbers. So I want to relate this back to a process that we've seen before, which is multiplying whole numbers. For instance, when we're multiplying something like 4 times 3, we see that that's repeated addition. So 4 times 3 means I have 4 3 times, right? Or I have 3 of the 4s. So we can kind of replace that word of with the operation of multiplication. So the word of implies multiplication. So when we're looking at something that's a little more abstract, like 3/4 times 1/2, well, that means I want half of 3/4. So half of 3/4. What does that look like? Well, here's what 3/4 looks like, right? If I said I wanted half of 3/4, 1/2 of this 3/4, that's the result of multiplying 1/2 and 3/4. Well, let's use the picture to try to figure out what half of 3/4 actually looks like. So if I took this 3/4 that I see in the picture here, and I actually took half of that, what is half of that going to look like? I can make that look a little nicer. Let me fix it up. Half of that looks like, well, this is the half of that 3/4. And that's really just 1, 2, 3 out of the 3, 4, 5, 6, 7, 8 total regions now that are created. So half of 3/4 is actually 3/8 altogether, which means if I was to multiply 1/2 times 3/4, I end up with 3/8. So what are we doing? Well, we're kind of skipping a step here, but we're using a property in reverse that we talked about before. We're simply going to make this one fraction where we can multiply our numerators to get the top, and we can multiply our denominators to get the bottom. So the 1 times 3 on the top gives us 3, and the 2 times 4 on the bottom gives us 8. Okay, so multiplication of fractions isn't too terrible. We are just using the property we talked about in our last topic, but in reverse. So in the last one, we started with this one fraction we separated into two. Well, now we have two fractions, and we're going to put them together to make one. Okay, but the same concept. So to multiply fractions, we're just going to multiply the numerators, and we're going to multiply the denominators. And we just want to make sure that our answer, our final product, is a fraction that is in its simplest form. Okay, so let's look at a few examples. So if we were to multiply 2/3 times 5/11, we can get one fraction here by multiplying our numerators, 2 times 5, and multiplying our denominators, 3 times 11. So 2 times 5 in the numerator is going to make 10, and 3 times 11 in the denominator is going to make 33, and those have no common factors, so the product here, the answer here, is 10 over 33. Okay, similarly here, we could make this one fraction where we multiply our numerators and we multiply our denominators, and so we end up with 1 over 8, no common factors. That is our product in its simplest form. Okay, hopefully this feels pretty easy, right? So same thing here. We're going to multiply our numerators, 3 and 5. We're going to multiply our denominators, 8 and 7. So 3 times 5 is 15. 8 times 7 is 56. And we have no common factors, so again, 15 over 56 is going to be our product, our answer. And then one more time, let's multiply our numerators, let's multiply our denominators, and so 1/18 is going to be our product. Okay, it's not so bad. Now, these happen to all be, the first four here, all be products that are already in their simplest form. That's not going to happen every time. So let's look at a couple more where we actually have to do a little bit of reducing or simplifying. So here, for instance, when we make this one fraction, we multiply our numerators, 6 and 14. We multiply our denominators, 7 and 27. Before we actually multiply, I can already see that we're going to have some factors in common, because I know 14 and 7 share a common factor of 7, and I know that 6 and 27 share a common factor of 3. So instead of multiplying, I'm going to take these numbers apart and see if I can simplify. So for instance, the 6 I could rewrite as 2 times 3, and the see here, the 14 I could rewrite as 2 times 7. So I'm taking all this apart, and then on the bottom I could rewrite the, let's see, the 7's going to stay. I can't break 7 down any further, but the 27 I can break down. So 27, running out of highlighter colors here, 27 I could rewrite as 3 times 9. And if I wanted to even take that further, I could rewrite the 9 as 3 times 3. So 27 could be 3 times 3 times 3. And so we can see now that there's some simplifying we can do. We can do some reducing here. So I know that the 7 divided by 7 is going to reduce to a 1. And I know that a 3 and a 3 is going to reduce to 1. And I don't see anything else in common, which means now we can multiply and get our result in its simplest form. So 2 times 1 times 2 times 1. Well, that's going to be 4 in our numerator. And 1 times 1 times 3 times 3 is going to be 9 in our denominator. And 4 and 9 have no common factors, which means 4/9 is going to be my simplest form. Now remember, we have a calculator that can verify our work for us. I just want to make sure you know how to use your technology. So if we were going to use technology, 6/7 multiplied by 4 over 27. And remember, it's going to give us a decimal, but if we hit that little fraction picture in the blue, it's going to tell us that that product reduces down to the same thing we got, which was 4/9. Okay, let's try that one more time here. So on the top of the fraction, we're looking at multiplying 23 and 4. On the bottom, we're looking at multiplying 32 and 7. And those are some big numbers to multiply, but again, I probably wouldn't multiply yet because I can see that my 4 and 32 have a common factor of 4. And so if I want to try to simplify this first, then I'm going to leave the 23. I can't do anything with that. That's a prime number. But and I'm going to actually leave the 4 here alone also. What I'm going to do is I'm going to rewrite the 32 as a factorization of 4 times 8, since that's the factor I saw they had in common. And then I'll leave the 7 there as well. So now we have some 4's in common, and I know that 4 divided by 4 is going to reduce to 1. And so what's left on the top of the fraction is 23 times 1, which is 23. And on the bottom, 1 times 8 times 7, which is going to be 56. And I know there won't be any common factors here since 7, 8, and 23 have nothing in common. This has to be the simplest form for my product. And again, we can use our technology to verify. So 23 over 32 multiplied by 4 over 7 ends up reducing to 23 over 56, and that is what we had, so we're in good shape. Okay, so far, hopefully so good. We have sometimes those situations where we're multiplying fractions with mixed numbers or fractions with whole numbers, and that's something we should be prepared to do as well. So a couple things first. Remember that dividing any number by 1 is itself. So if we had, let's say, 20 divided by 1, that's just 20. Or if we had 15 divided by 1, that's, sorry, I said 1 and I wrote 15. 15 divided by 1, that's just 15. Okay, so therefore, if we have a whole number, any whole number, if we start with our whole number and we want to make it a fraction, we can just divide it by 1 and not change its value. So I can start with a whole number and make it a fraction by dividing it by 1. Okay, so we can write any whole number as a fraction by dividing it by 1. Also, we know how to take mixed numbers. We can take mixed numbers and rewrite them as improper fractions. Do you remember how to make a mixed number an improper fraction? So for instance, if I had 2 and a 4th, I can make this an improper fraction by multiplying my denominator and the whole number part to make 8, and then adding my numerator. So 4 times 2 makes 8 plus the 1 is my new numerator, and my denominator stays. So this ends up being improper fraction of 9/4. So what we want to do before we multiply fractions by mixed numbers or whole numbers is rewrite our mixed numbers and our whole numbers as improper fractions. Okay, so if we have a mixed number or a whole number, we got to make them improper fractions first, and then we can do our multiplication. So for example, here we would change the 3 1/3 to an improper fraction. So this would be multiplied and then added here. So the 3 times the 3 plus the 1 over 3 is going to be 9 plus 1, which is 10 over 3. So 3 1/3 becomes 10/3, and we're going to be multiplying by 7/8. And that's going to get us, let's see, on the top of the fraction, I know I'm going to have a common factor here. I can see that the 10 and 8 have a common factor of 2. So let's see. Let me not take too many shortcuts here. We're going to be looking at 10 times 7 in our numerator, right? And we're going to be looking at 3 times 8 in our denominator. But again, I can see that the 10 and the 8 have a common factor of 2. And so 10 I'm going to rewrite as 2 times 5, and I still have a 7 there. And then 8 I'm going to rewrite as 2 times 4. So now I can reduce the 2's, the 2 divided by 2, to 1. And so what's left is 1 times 5 times 7, which is going to be 35 in my numerator, and 3 times 1 times 4, which is going to be 12 in my denominator. And that's going to be the simplest form, and I know that because the 5, 7, 3, and 4 have no common factors, so the 35 or 12 won't have any common factors. Okay, so there's that. Let's try again. Let's see, 3/4 this time multiplied by 20. So 20 is a whole number that we can make a fraction by dividing it by 1. So all we're looking at here is one fraction where we multiply 3 and 20 in the numerator and 4 and 1 in our denominator. But again, I can see a common factor here of 4, and so I'm going to rewrite the 20. Oops, let's turn the pen back on. I'm going to rewrite the 20 as a factorization of 4, and it goes in 5 times. And then again, we have this 4 and 1 in the bottom. Well, now I can reduce. 4 divided by 4 is going to be 1. And so what's left in the top of my fraction is 3 times 1 times 5, which is 15. And in the bottom, 1 times 1, which is 1. Now, 15 over 1 wouldn't be incorrect, but because 15 divided by 1 is exactly 15, that would be a better answer, a better way to write that answer. Okay? And again, this can be confirmed with the calculator. We want to do 3 over 4 and multiply it by 20, and there it is, 15 as our answer. Now, I haven't tried mixed numbers in here. Let's see, if I wanted to put in 1 and 2/3, what I would need to do in Desmos is put a plus sign between those. I don't think it's going to recognize 1 and 2/3 like that. Or maybe it will. Let's see. Oh, yep, it sure does. So if you want to put in a mixed number, we can do that as well. Let's verify which one did I do up here. 3 1/3. So let's put the, I think if we just try to type 3 1/3, that's not going to be good. That's not what we want. So let's put in the 1/3 and then go back and give it that coefficient, or I don't want to give you a new word, give it that whole number part of 3. So 3 1/3, and we want to multiply by 7 over 8, and it gives us 35/12, and that's what we had there. So mixed number, you got to be a little tricky about putting it in. You're going to have to either do the 3 and then add the whole number, like get the whole number part and then add the fractional part, or you can take the plus sign away. You just won't be able to type it all in one shot because it will like connect the 1 with the 3, which is not what we want. Okay, so just be a little careful if you're going to try to put mixed numbers in there. Alright, let's try another one here. We've got 2 mixed numbers to convert. So let's see, 3 times 1 plus 2. 3 times 1 plus 2 over 3 is going to be 5/3 here. And then 2 times 4 plus 1 4 times 2, plus 1, same thing, divided by 4 is going to be, 4 times 2 is 8 plus 1 is 9, so we're going to get 9/4 there. So this is going to be the same thing as multiplying 5 over 3 and 9 over 4. So we are looking at 5 times 9 in our numerator and 3 times 4 in our denominator. Now I can see a common factor of 3 here, so I'm going to go ahead and rewrite my numerator as 5 times 3 times 3. My denominator is going to be fine, but that's going to allow me to reduce out a pair of these 3's to 1's. And so what are we left with? Final answer here. In simplest form is 5 times 1 times 3, which is 15, and then 1 times 4, which is 4. So 15/4 for my simplest form. Okay? And then one more, if you're feeling confident, I think this would be a great place for you to pause the video and try this out. See what we got here. So first, I'm going to make the 7 a fraction by putting a 1 under it. And then here, I'm going to multiply and add. So 14 times 2 plus 11 over 14. That's going to be 28 plus 11, which is going to be 39. So 39/14. So I'm looking at 7 over 1 multiplied by 39/14. And so we can make this one fraction. 7 times 39 in the numerator, 1 times 14 in the denominator. But again, I see a common factor of 7 here. So I'm going to rewrite this as 7 times 39, and on the bottom, 1 times 2 times 7, so that I can reduce the 7's to 1's. And so I'm left with 1 times 39, which is 39 in the numerator, and 1 times 2 times 1, which is just 2 in my denominator. Okay? And so 39 over 2 is going to be our result. And I just want to show you here, back at this step. So 7 times 39, and we had 1 times 14. Remember, if you don't want to write out the factorizations and divide, there was another shortcut. That's a shortcut on its own, but there was another shortcut. So if you can see the common factor of 7, and you want to divide by 7 here and divide by 7 here, that would work as well. So 7 divided by 7 is going to make that a 1, and you'd be left with the 39 on the top. And then 14 divided by 7 is going to leave you a 2 there. And then 2 times the 1 would be that same 2 in the denominator. So if you want to divide that way is fine. This is really kind of whatever works best for your line of thinking, okay? And the great news is calculator will do all of this for you. So by all means, use your calculator to assist you in this work, and at the very least, to verify or check your work. Because as we know, we make mistakes. We're all human. Okay? So I think you have enough to go on for the practice here, but as always, if you need any additional help, then just reach out. Alright guys, take care.